yesterday we talked about reflections, and today we're going to talk about translations. And translations is basically a slide that allows you to move a figure left, right, up, down, okay? And you actually move it through a vector, okay? And a vector is a directed distance, okay? It's like a ray, but a ray goes on indefinitely. A vector goes from point A to point A prime, okay? It goes a certain distance in a certain direction. So, like if I were going to fly from here to Dallas, I fly through a vector because I go from here to there in a particular direction. Anytime you fly in an airplane or you fly an airplane yourself, you have to file a flight plan with the FAA. Why do you think that is? So the planes don't crash into each other, right? Okay, because they have to know who's going where, at what altitude, and whatnot, okay? And we're going to talk more about vectors at the end of the year. We'll have a little lesson, but there's a whole study devoted to vectors called linear algebra. Okay, so this is a vector. It looks kind of like a ray, except it stops at this point and it goes through a particular direction. When you denote a vector, it's kind of like you do a line. You use a lowercase cursive letter, but then you put this little half of a ray, which is a vector symbol, over the top of it, and that's what's on top of that little K. All right, so a translation is a function that maps each point of a figure the same distance in the same direction. When you slide something, you're actually sliding it through a vector, okay? And we're going to talk about two ways that can be done or shown how to be done. This right here is my function notation. And this is my translation vector. They both mean the same thing. It's just two different ways to express it. All right, so we are going to, we've graphed this rectangle. It's already graphed for us, PQRS. And we are going to graph its image for the translation XY maps onto x plus 3, y minus 5. And so what that means is that every x coordinate you're going to add 3 to it, and every y coordinate you're going to subtract 5 from it. All right? And so you're going to do add 3, minus 5, add 3, minus 5, add 3, minus 5, add 3, minus 5. So each one, okay? So my P prime now is going to be located where? At the origin, 0, 0, good. Q prime is going to be -1, -3. R prime is going to be 4, -5, and S prime 5, -2. Okay, so let's come up here and graph that. Here's P prime. Q prime is at -1, -3. R prime is at 1, 2, 3, 4, down 1, 2, 3, 4, 5. And S prime is at 1, 2, 3, 4, 5, 2. All right. So we connect those points. And we have translated PQRS, I can't say it right, PQRS, we have translated it through that vector. And you can see that if I draw it, each point is going the same distance in the same direction, so it's translating it through that vector. Now, the other way that you can denote it is with a translation vector, okay? And it means the same thing, except where you kind of write it as an ordered pair, but instead of putting parentheses around it, you put these little sideways V's, V for vector. I don't really know if that's what their intention was, but that's what I think of it as, all right? And so if you see something like this right here, that means you're going to add 3 to the x coordinate and subtract 5 from the y coordinate. Or you're going to move 3 to the right and down 5, all right? Which is in essence what we did. Okay, so it says graph each figure and its image along the given vector. And it gives us the vertices. Now, I've already got it graphed here. This is E and F and G. Okay? And it wants us to translate it along this vector. So I have to find the location for E prime, F prime, and G prime. Okay? So what does this vector 2, 5 tell me? What does it mean that I'm going to do? Add 2 to the x and add 5 to the y, right? Plus 2, plus 5, plus 2, plus 5. Okay, so my E prime is going to be what? Negative 5 and 4, right? Negative 1 plus 5 is 4. What's F prime going to be? Negative 2, 1, and G prime is going to be negative 1, 4. Good. All right, so if I graph this, negative 5, positive 4, and F prime is negative 2, 1, and then G prime is negative 1, positive 4. Okay, so again, I have translated that through the vector 2, 5. I went 2 to the right and up 5 for each point. All right, now we're going to work backwards. We're going to see a translation, and we're going to come up with the function notation or the translation vector. So it says describe the translation from star 1 to star 2 in function notation and in words. So let's do it in words first. Now when we do this, we're wanting to go from star 1 to star 2, but we want to translate the same point on both, all right? So let's say we pick the top of star 1, and we want to figure out what we have to do to get to this top of star 2, all right? So to get there, what do I have to do? Okay, the first thing you do is left or right. So you go to the right, 1, 2, 3, and you go up 2, okay? So if we were to put it into words, we would say translate 3 units to the right and 2 units up. Okay, that would be the good math words to use. What? Well, the directions ask me to express it in words and in function notation. So you have to know how to do both, all right? The next one we're going to do a vector notation like what you're wanting to do. All right, so that's how I put it in words. Now I want to express it as a function, okay? So when you express it as a function, you take your ordered pair, which is x, y, and it's going to map onto, and what would my function notation be here? Okay, that's the vector translation. I'm wanting function notation, huh? X plus 3 and y plus 2. Okay, there's 2 different ways that you're going to see it, so I want to make sure you understand how to do it when you see it either way, okay? And this is function notation. All right, now, in the next one, they want a vector translation, okay, or translation vector, all right? And so in this one, we're going to go from 3 to 5. We're going to go from 3 to 5. Now, let's put it in words first, and then we'll write the translation vector. To get from 3 to 5, what do I have to do? Left 1 and up 1, 2, 3, 4, 5. Okay? So, translate 1 unit to the left and 5 units up. Okay, and so Sam, what would my translation vector look like here? Okay, so it would be vector negative 1, 5. And what goes on either side? The little sideways V's, that's important, okay? Because if you just put parentheses, that indicates an ordered pair. And that's what we're actually moving, is the ordered pair. And we're moving it through this vector, okay? Now, have any idea when you might ever somebody might ever even use this concept? Is it just something totally useless? Yes. Okay, I can see that, definitely. All right, yes. Missiles? Like for battleship? A missile, you would use a vector, definitely, yes. Okay. Have you ever played, yes. Okay, an architect, yes, you're going to translate something. Have you ever watched a Disney movie, Pixar? Yes. Okay, what about a video game? Have you ever played a video game? How do you think, how do you think they make those things move?
Translation.
They translate them, okay? They translate them. They do this. When I first started teaching here, I taught computer programming, and one of the projects that we did is we learned how to make something move. Okay, and when we made it move, we had to use this right here. Okay, so that may not be the path that you want to take, but this is something that is actually applicable to something that somebody does out there. Okay, we'll all do something different. All right. Your assignment is on the board.